We're going to put together a set of axes. Down the bottom here, it's always helpful when you have a graph to say what's it talking about. I don't actually know what this is at the moment, so I'm just going to call them scores. But say something rather than nothing, because then if you have temperatures or heights or something like that, then you remember to describe it. I'm going to call these scores. I want to make sure my data can go from the bottom all the way up to the top. So I'm going to start from 3, and then I'm going to go up and draw some sort of increments along until I get to 15. I guess I'll go in 3s because conveniently 15 is a multiple of 3. So I'm going to go 3 and then 6. Okay. So I've got everything evenly spaced. It's pretty important that things are to scale here because you're trying to make arguments on the shape of this graph. So things need to be evenly spaced out if you're saying that that's really 3 and that's really 3 and so on. Okay? Now, your 5 numbers, all you need to do is to know what the numbers are and place them in the appropriate spots onto here. Just a bit above though, we're going to hover them. So here's 3, I'm going to draw a vertical line above 3. This is my minimum. 4.5. 4.5 is exactly halfway between 3 and 6, which is kind of convenient. Okay. So down here, I'm going to draw another vertical line for 4.5. Because 4.5 is not on, it's not one of the points that I labeled down here. And I don't want you to waste time going like 3, 4, 5, 6, 7, 8, do all the digits. It's just going to become really full, and you still won't have 4.5 on there anyway because it's a half. So I'm going to draw some dots down like this and label that as a value so that I have it precisely. Next number along. What is the next number along? 7? 7? You can see I'm trying to put all these vertical lines nice and parallel to each other and horizontally. 7, again, was not a point that I had labeled before, so I'm labeling it now. What's my next one?
9. Okay. 9.
9? It's 9, right? Halfway between 8 and 10. Yeah. So 9 is conveniently already marked in. And then the last one is 15. Okay. So my 5 markings correspond to the 5 numbers in my 5 number summary. So now I'm going to make the box and the whiskers. The box is in the middle. The box represents the interquartile range. So here's the interquartile range here. So I'm going to draw a line across the top and across the bottom. And there's the box that box plots are named after. Okay. How do I draw the whiskers? Does someone remember?
Whiskers.
The whiskers. Where did the whiskers go? So you might have seen these before, we haven't done them in detail. The whiskers are the outside bits, right? So instead of, I want to distinguish them from the box, so I'm going to draw them in the middle. What? Like that. Okay, you should have seen this at least once before, even if you didn't deal with it in detail. Okay. So this is a box and whiskers. Okay. This box and whisker plot now describes to us, just at a glance, what is this data set? What does it look like? How would you describe it? Okay. So, on top of this diagram, I'd like us to put a few labels in here. These guys in the middle, the box, right? This is the middle 50%. Half of the people, the most average of the people, right? Half of them are here, between 4.5 and 9. That's the middle 50%. Why do I know it's 50? How do I know 50?
Because the interquartile range is 50% of the scores.
Okay, because these quartiles divide up my scores into, remember, 4 equal sections, that means there's the same number of people here, and here, and here, and here. Does that make sense? So I can also say, there's the middle 50%. Here is the lower 25. And lastly, this is the upper 25. Oops. There we go. Okay. So, from this box of whisker plot, what can we conclude? Well, we can see where the median is. This is where the middle score is. Half below, half above. When you look at this, see how there's a really long whisker over here? What does that mean?
Outliers.
So, outliers are people who are outside the normal range, okay? We would usually say the top and bottom people usually are outliers, but not always. For example, these scores are all between 3 and 15. Suppose it was a test out of 15, okay? You remember I gave you that weird set of data before that was just like 5s?
Yeah.
Right, do you remember that? Okay. If someone got 4 and someone got 6, I don't think you would call either of them outliers, would you? Like, they're right next to everyone else. Does that make sense? So just because they're the top and bottom doesn't make them outliers. People who do mathematics standard next year will learn there's a formal definition for that. I won't worry about it at the moment. What I gather from this thing here is that this top 25% is really spread out over these marks. Does that make sense? Just imagine this. See how there's 4.5 here? Imagine if I put the lowest score as 4. What would that mean? For this set of scores, remember, each of the 5 numbers separates out. There's 25%, 25%, 25%, 25%. Yes, it has to do with skew. That's right. So this here, see how they're really close together? That means 25% of people are all squeezed into there in a tiny little space. Okay. So that means if I were to draw this, it would look like this. You have a name for this, don't you? What's this called?
Skew.
It's skew, but the tail is going positive. So this is positive skew. Okay. So another way of thinking about this is, if you have a box of whisker plot, you don't need to graph it in another way. Have a look at which whisker is longer. The longer whisker is a tail. So this, I can see it straight away, is positively skewed. Okay?